Ever wondered how your car just knows things? Like how it knows the engine is too hot, or that you're running low on fuel. It's not magic. It's a constant, high-speed conversation happening right under the hood. And today, we're going to eavesdrop on it. Welcome back to CodeMechanic. Think of your car's computer, the ECU, or engine control unit, as the brain. But a brain is useless without senses, right? That's where sensors come in. You've got dozens of them scattered all over your vehicle, acting as the eyes, ears, and nerve endings. They measure everything: temperature, speed, oxygen levels, the position of the crankshaft. Name, Italiano. So, how do these sensors actually talk to the brain? Most of them don't speak in plain English. Instead, they use the language of electricity. Let's take a simple temperature sensor. It's often a type of resistor called a thermistor. When the engine is cold, its resistance is high. As it heats up, the resistance drops. The ECU sends a small, constant voltage to this sensor, let's say 5 volts. By measuring how much of that voltage comes back, the ECU can calculate the resistance, and from that, the exact temperature. It's basically solving a tiny math problem hundreds of times a second. It gets even cooler with other sensors. Take the crankshaft position sensor. This one is Vitalit. Tells the ECU exactly where the pistons are in their cycle, so it can time the spark plugs and fuel injection perfectly. Many of these work using something called the Hall effect or magnetic reluctance. As a toothed wheel on the crankshaft spins past the sensor, it creates a fluctuating magnetic field. The sensor converts this fluctuation into a digital signal, a series of on and off pulses, like a super fast Morse code. The ECU reads this pulse train and knows not just the position, but the exact speed of the engine. But what about more complex information? How does the airbag system know when to deploy? This involves an accelerometer, a tiny sensor that measures rapid deceleration. If it detects a change in speed that is way beyond normal braking, like hitting a wall, it sends an urgent high-priority signal to a separate airbag control module. This module then makes the split-second decision to fire the airbags. It's a dedicated communication line for a critical safety function. All these different electrical signals, the varying voltage. The digital pulses are sent through a complex network of wires called the wiring harness. Think of it as your car's nervous system. This used to be a simple point-to-point system with a separate wire for every single signal. But in modern cars, that would mean miles and miles of copper, which is heavy and expensive. So, engineers developed something brilliant called a CAN bus, which stands for Controller Area Network. Imagine a conference call where everyone is on the same line, but they all speak in turn and state who they are and what their message is. The CAN bus is like that. Multiple sensors and control units share the same 2 wires. Each one broadcasts its data as a packet, which includes an ID saying who it's from and the data itself. The ECU and other modules listen in, but they only pay attention to the IDs they care about. This drastically simplifies the wiring and allows different systems in the car, from the engine to the radio, to share information seamlessly. So, from a simple change in resistance to a complex digital network, that's how your car's sensors talk to the computer. It's a non-stop, invisible orchestra of data that makes your modern vehicle work. Pretty amazing, right? If you enjoyed this peek under the digital hood, hit that like button and subscribe for more deep dives into automotive tech. Thanks for watching CodeMechanic. See you in the next one.